Hello everyone, welcome to our YouTube channel Electronics Maddie. In this video, I am going to demonstrate simulation of fuzzy logic based buck converter in MATLAB Simulink. In case you haven't subscribed to our channel, please do subscribe to it so that you'll be getting the videos that we post regularly. Alright, let's get into our topic for today. This is the MATLAB model of fuzzy logic based buck converter circuit. I've already made a couple of videos. One is with respect to design and simulation of buck converter, and the other is with respect to closed loop simulation of a buck converter circuit. So in case you haven't watched that, you can always watch that. That will give you a clear understanding with respect to the design process of a buck converter circuit. So how is this particular circuit different from the closed loop buck converter circuit? So I'm using a fuzzy logic controller instead of a PI controller. The reason being the peak overshoot is drastically reduced and the steady state error is also reduced in case of a fuzzy logic controller. And that is why these type of controllers are popularly used in industrial applications. So how do we design such type of a circuit? That is one of the most important aspects, isn't it? So there is something called as fuzzy logic rule where we will define what has to happen within the fuzzy logic controller, and consequently the fuzzy logic controller will provide the desired output. So the inputs for the fuzzy logic controller, so there are two inputs, the error and the change in error. So the change in error is basically the error that is holding the previous value of the error. So how do we do that? I'll explain you in MATLAB. So these are the two inputs. So PB stands for positive big, PM stands for positive small, positive medium, PS stands for positive small, Z stands for 0, NS stands for negative small, negative big, and negative medium and negative big. So the same holds good over here as well. So whenever there is the actual value of error and the change in error is with respect to these values. So if there is positive big and negative big changes, then consequently the output should be equal to 0. These are the duty ratio that are defined over here. So this basically happens to be the duty ratio that will be given to the MOSFETs. So for example, if you carefully observe one point, when it is positive big, negative big, or positive medium, negative medium, so the diagonal values are equal to 0. The reason is because if there is positive big changes in the actual error, then the changes in the previous value of the error will be negative big, and consequently positive big and negative big will be cancelled out and it will be equal to 0 because I'm using a summing block in the MATLAB. So that is why all these values are 0. However, if there is another example, if you need to consider, if there is positive big and negative small, you will be considered the duty ratio percentage to be equal to 50%. So if there is positive medium, so positive medium is comparatively lesser than positive big, isn't it? And you're doing it with respect to negative small, comparing these two values. So I'm considering a slightly lesser value, say equal to 5% of the duty ratio. Now again, positive small, negative small will cancel out, it will be equal to 0. 0, basically negative small will be greater than 0, that is why it goes to the negative value. So negative is minus 5. Negative small, so basically it will again add the negative values, it will be equal to minus 50. I hope the logic with respect to defining the duty ratio over here is understood. So these are the values that are very important, and this is what we will be entering in the fuzzy logic rule in fuzzy logic controller. So be very careful, keep a note of this particular table or take a screenshot of it. This will be pretty handy while entering the values in the fuzzy logic controller. So all right, let's go to MATLAB and start our simulation. So all right, here I am in MATLAB. So at the first place, before getting into the Simulink window, let us type fuzzy and click on enter. So you will have to wait for some time. So you get a pop-up like this, which is called as fuzzy logic designer. Over here, you have to design the fuzzy logic controller. That is the most important aspect. Once you design fuzzy logic controller, remaining things is pretty much straightforward. You will be able to do it. So at the first place, let us start off with defining this particular controller. We will be requiring another input. So go to input and add variable and then click on input over here. So once this is done, now I will be changing the input names. So basically this is called as error, and this is called as change in error. So you can consider it as change in error or change error. So consequently the output will be duty ratio, so you can type it as duty. So this is done. So we have named the input and we have named the output. So double click on the error block, so you will be getting something like this. You can click on any of the three inputs or the output block and you will be getting this window. So what is this over here? So here is where you have to define the membership functions. So basically you had something like this, isn't it? So what we have to do, you have to click on remove all membership functions. So membership functions basically are basically the signals that will define the logic that is to be held with respect to the circuit that we are building. So click on edit and add membership functions. So let it be the waveform be triangular in the same fashion that it is. So we will be requiring 7 membership functions. So select 7 and consequently you'll be getting membership functions in this particular fashion. Major things that you have to do: rename all of them in this particular fashion. Negative big, so you'll start off with negative big, then you will be having negative medium, so NM, then click on this, change it to be equal to negative small. So once that is done, change this to be equal to 0, that is basically Z. Change this again to be equal to positive small. So we are going in the same hierarchy, and that will be followed for the next input as well. Positive medium, then we will be left out with positive big, so PB. So once we have entered all these, so you can go into the next input, that is the change in error. So over here again, go to edit, remove all membership functions. So let us add membership functions. We need 7 membership functions. So click on OK. So these are basically signals. So that is from a specific range. So when there is coinciding values between these two errors, the duty ratio will be decided. So that is how the logic works. Now again, over here, change in error, we have to give the values of the individual blocks. That is negative big we'll be starting off with, then we will be requiring negative medium, then you will be requiring negative small, then you will be requiring 0, which is in the middle, which is represented by Z. Then we will be requiring positive small, so enter P, yes. Then we will be requiring positive medium, enter PM. Then we will be requiring positive big, so PP. So once this is done, the next step is to click on output, that is basically the duty. So remove all the membership functions again. We will be defining our own rule over here. So add membership functions again, let it be 7. So click on OK. So done. Now we will be entering the values over here in duty ratios. So we will be starting off from -100 and click on this. It will be -50 and this will be, so you can change over here. This will be -50 and this, select this and change it to be equal to -5. This will be equal to 0. This will be equal to +5, again in the same hierarchy. So this will be equal to +50 and this will be equal to +100. So once this is done, you can cross check if all the membership functions with respect to input and output variables are defined. So you have all the values entered. Again, with respect to this, you have all the values entered with respect to the output. So now you can close this window. You'll be left out with this window: error, change in error, and duty. So now we have to define the rule. So how do we define that? Double click on the untitled block and you will be arriving at this window called as rule editor. Over here we will be defining the rule. So now keep the reference of the table that I had already shown you. So with respect to change in error, so this is basically the actual error. So actual error, if it is say equal to PB, and if this is say equal to NB, so I'm basically going on with respect to rows. So when this is NB and this is PB, what should be the output? So AND logic should be used and the output should be equal to 0. So click on 0 and click on add rule. So now let me keep this constant because with respect to first row it is always NB. Now let me only change this. This should be PM and consequently this should be -5. Add rule. So once this is done, now this should be PS. So the change should be -50. So add this. Click on add rule. Let it be AND. So when both of them are in these values respectively, the duty ratio in percentage should be this much. That is what we're trying to do. So once PS is also added, our next block is 0. So click on 0 and this value should be equal to -100. So add rule. So once this is done, next block is NS and the change should be -100 itself, so add rule. The next block is NM, the change should be -100, add rule. The next block is NB, the change should be -100, so add rule. So once this is done, we'll get into our next uh, row, that is basically nm with respect to change in error. So basically keep this change in error to be equal to nm, and now we will be changing these value, that is the error values over here. So again this will be starting off from pb, and the value should be equal to +5, add rule. So this should be equal to pm, and the value should be equal to 0, add rule. So this should be equal to ps, the value should be equal to -5, add rule. This should be equal to 0, and the value should be equal to -50, so add rule. This should be equal to ns, the value should be -100, add rule. And then this should be equal to nm, the value should be equal to -100, add rule. And this should be equal to nb, and again the value should be equal to -100, so add rule. So we have completed with respect to two rows. We still have five more rows to be done in the similar fashion. Now this should be changed, the change in error should be changed to ns. Consequently the values with respect to error, that is it starts off from pb, the value should be equal to 50. So start off from this point, click on add rule. So again this should be equal to pm, and click on the value to be equal to 5, add rule. This should be ps now, click on 0 and then add rule. This should be 0, and the duty ratio should be -5, so add rule. So once this is done, negative small, the duty ratio should be -50, add rule. This should be negative medium, and the change should be -100, add rule. This should be NB, the change should be -100 again, so add rule. So we've done three rows. The next row is with respect to 0, and we'll be starting off from PB again, and the values will be from 100. So click on add rule. Then we have PM, the value should be 50. We have PS, the value should be 5, add rule. We have 0, and then the value should be 0. Click on add rule. The value over here should be NS and -5 over here. So add rule, NM and -50 over here, add rule, NB -100 over here, and then add rule. So we've completed four rows now. The fifth row is with respect to positive small. So select positive small, and we will be starting off with PB again. So it starts from 100, add rule, PM 100, so add rule. Then you have PS, that is 50, add rule. Then you have 0, that is 5, add rule. And then NS is with respect to 0, add rule. And then NM is with respect to -5, so add rule. And NB is with respect to -50, so add this as well. So I hope you are understanding the logic with respect to adding these type of rules over here. So that is basically done based on the table that I'm referring to. So again now this should be PM, and this should be starting off from PB, and the value will be starting from 100. So scroll down, add this rule. This should be PM, and value should be 100. PS, value still should be 100. 0, the value should be 50. Then NS, the value should be equal to 5, add rule. NM, the value should be equal to 0, add rule. NB, the value should be equal to -5, add rule. So once this is done, we are left out with our last block, that is PB. So with respect to PB, the error values are starting from again PB, and the value should be equal to 100. So add rule. This should be equal to PM, add rule. Then PS, add rule. Then you have 0, add rule. Then you have NS, that is basically 50, so add rule. And this is NM, which is basically 5, add rule. NB, which is basically 0, add rule. So we have 7 rows basically, and we have 7 to 7 cross matrix, which is basically 49 rules that is defined in this particular fashion. So once rule is defined, we can click on close. All of these rules are defined now. So in case you want to double check, you can double click on it and cross verify. Now what should we do? Now we have to export this to a file. Save it in a specific folder that you would like to, and click on save. So this file name should be this file name plays a very important role, should be carefully made a note of, and this file name is what we are going to enter in the fuzzy logic controller. So you can just reduce this, and I'll be going to MATLAB Simulink now. Click on Simulink. So here we are in Simulink. Now I'll be placing the components that I want. At the first place, I'll be requiring a DC voltage source. So search for DC voltage source and add this block. So we are choosing the ones that are there in black, which is basically used for power systems and power electronic applications. The ones that are there in blue are basically used for signals and systems and digital signal processing applications popularly. So power give block is basically used as a compiler, so that will act as a compiler with respect to the circuit. And if you don't have power give block, it will basically throw you an error. We'll be requiring a voltage measurement block as well, so add that. We will also be requiring a MOSFET switch. Search for MOSFET and add that block. You will be getting it right at the bottom. Choose the ones that are there in black, so be very careful. And apart from that, we will be requiring a diode. Search for diode and add that block as well. Scroll a little down. So we will be requiring series RLC branch. So basically we'll convert them to inductors, capacitors and resistors based on our requirement. So once that is done, we will be requiring a scope in order to see the waveform. So just like oscilloscope that is used in hardware implementation or practical applications where we have to see the waveform, similarly scope is used in simulations tools. So once that is done, we will be requiring a constant block. This is with respect to feedback path. So I'll be entering the reference value over here. So add this block. Apart from that, I will be requiring a sum block. Search for sum, and you will be getting a subtract block over there. I'll be using them. So why are we searching for sum? Because we get all the blocks that are related to sum. That's why I'm using that. At the first place, let us search for PWM generator, and you will be getting the block with respect to that. Scroll a little down, you will be seeing something called PWM generator DC to DC. Add this block, and we will also be requiring fuzzy logic controller. So search for fuzzy. There will be two categorical classification of fuzzy logic controller. I'm not going with rule viewer because I've already defined the rule. So add this block. Once that is done, I'll be requiring a multiplexer. I'll tell you the reason why it is used. So let us first add a multiplexer. And apart from that, I will be requiring a memory element. So search for memory. I'll be explaining you the purpose while connecting the circuit. So add memory. So now let us place them in appropriate position so that we can get started with respect to the circuit construction part. So the scope is to be placed at this position, diode over here, and MOSFET switch over here, a power give block in this particular fashion. So the switch can be double clicked, and we'll be disabling the measurement port because we're not using them. Just not have additional terminals with respect to it. So click on OK. With respect to diode as well, we are supposed to do it. So once that is done, so you can rotate this, so it should be connected in this particular fashion. And I'm connecting to the diode, and I'm going to convert this to an inductor, and its value is chosen to be equal to 65 millihenry. So enter 65 over here, and we will be requiring a capacitor. So copy paste this and rotate it by pressing Ctrl R. The value of the capacitor is 150 micro, so enter that. We will be requiring a capacitor, we'll be requiring a resistor block, so copy paste that. And the value of the resistor that is chosen is 10 ohms, so enter that value as well. So click on OK. Now we'll be connecting the circuit according to the circuit diagram. A capacitor filter is used and a resistive load is connected in this particular fashion. Now I'll be connecting the voltage measurement block between these two terminals, and I'll be giving it to the scope. Double click on the DC voltage source and change its value to be equal to 24 volt. That is basically our input, and we'll be reducing the output voltage to 12 volt. So now we will be rotating this. We'll be rotating this as well. So this is the reference value. This is the actual output voltage that you're getting. So whatever output voltage that you want, enter it over here. That will be the reference value. So I'll be designing it for 12 volt and connect it to here at this particular point. So once that is done, I will be requiring another subtract block. So I'll tell you the reason. This is the error value, isn't it? Now I'll be giving it directly at this point, and I'll be rotating this, and this will be the change in error. So it basically gives you the previous value of the error. So the error value and this memory holds the previous value of the error, and it will be basically given to this block. So this is the error and this is the change in error that is obtained. So consequently I'll be giving it to a multiplexer in this particular fashion. So one of the values will be taken from this point and the other value will be given from this point. Rotate this, give it to the fuzzy logic controller, rotate this PWM generator and give it to this, and consequently it will be given as a gate terminals of the MOSFET switch. So basically what are we trying to do? The error value is measured, the value previous value of the error is being stored in this particular memory element block. So you can double click on this. We don't have to change anything with respect to the memory element, so you can check. So you don't have to give any initial condition. So it basically will store the previous value, and again this will give you the change in error, the error change in error values. These are two inputs that are given to the fuzzy logic controller. Based on the input values that are there, consequently it will produce the output, that is nothing but the duty ratio that is given as an input to the PWM generator, which is consequently given to the gate terminal of the MOSFET switch. So I hope the logic is now clear with respect to the simulation of this circuit. So once that is done, double click on the fuzzy logic controller. So whatever name we had given over there, so while generating the file for the fuzzy logic controller, so enter the same name of the file and it will automatically import it based on the folder location that you have chosen. So I had created the file name as MPPT. So I'm actually typing in over MPPT. FIS should be the extension of it. Click on OK. So now the file is being imported to the fuzzy logic controller. So the inputs that are there, so multiplexer is basically used in order to accept two signals and produce one particular output signal over here. That is why we're using a multiplexer, in order to have multiple inputs and a single output line based on the functionality of the circuit. Now one of the most important things to remember is to change this into discrete domain, because it takes a lot of time for the simulation to take place, because there are a lot of rules that are defined. So that is why it takes a lot of time. So in order to understand and analyze each of the fuzzy rules that are created, it takes a lot of time for the simulation to run. So if it is in discrete, for in comparison with the continuous domain, it will take much lesser time. As a result, we'll be going for that. Now let us click on run simulation and wait for the simulation to run for some time, and we will be able to check the output waveform. So this is sufficient, so we can click on stop. So now we will double click on the scope in order to see the output waveform. So if you carefully observe, we are getting almost 12 volt. The ripple is also comparatively much lesser, and this is exactly what our output waveform should supposed to be. Now we can change the value of the load. For example, we can change it to 20 ohms and change the supply as well to a specific tolerance limit. So there will be a limit, we cannot change beyond that. Let us say we are changing it to 20 volt. We should still be getting the same output voltage, that is 12 volt, because this is a closed loop system. The fuzzy logic controller should accept the changes. Consequently, it should produce the duty cycles accordingly. Let us see if it does that. Let us click on run, and again it takes some time for the simulation to run. So let us wait for some time. So we can stop the simulation now, and we can double click on the scope in order to see the waveform. So if you carefully observe, we're still getting 12 volt, which is exactly what we're supposed to get. So what can we conclude? Even if there is any sudden change in the load, or if there is change in supply within a specific limit, the output will still be equal to 12 volt. So as a result, since it produces constant output voltage of 12 volt with better steady state response and less peak overshoot, so fuzzy logic controller plays a very important role in nowadays applications. Like if you use MPPT techniques, fuzzy logic technique is one of the most prominently used techniques. So I hope you were able to simulate fuzzy logic based buck converter on your own. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. We'll meet you guys in another video. Thank you.